These questions also often show up on AP exam. Just being asked to estimate derivatives at a point, and they may just give you a table. So I want us, this is very simple to do, but I want us to think about what we're doing so we make sure we understand what we're doing and not just, and why we're doing it, and not just, you know, saying, oh, that's easy, but not really getting why we do it. So if I go to Desmos real quick and we graph these points, let's add a table, and we got 1, 0, 2, 5, 8, 15, 10, 11, 17. Alright, so we've got these points right here, and we're being asked to estimate f prime of 4. So 4, zoom in a little bit, 4 is going to fall about right here. And these points are a little strange. I probably didn't graph them whenever I was looking at them, but you can see, like, we basically have a line, right? It looks almost, I don't think that one's perfectly in line, and definitely this one's not perfectly in line, but we've got this graph here. So if we want to know the derivative at 4, would it be better for us to look at, like, the endpoints of this, or to look at your points that are closer? Closer, because we want to know at that specific point, right? So the average actually isn't going to be bad on this one because those points right there are in line. But the points closest to what you're looking for, or the points you're looking for, are the ones that you want to use. And if we're looking for the derivative, that is our slope of the tangent line, we obviously aren't going to be able to find the exact slope, but we can find the slope of the secant line that's closest to it, and that'll give us our best estimate. So, for this one, those points are right here at 211 and 57. So we would do f prime of 4, and then we are going to use squiggly equal signs. The squiggly equal signs means approximately. Technically, it's a good idea to use these anytime you round something. So if you round something off to 3 decimal places, but it actually had more decimal places, it would be a good idea to use the squiggly equal sign instead of using the actual equal sign. But I don't always do that. I do try to make sure here that I use this approximately symbol because we are just estimating. This is not the exact value for f prime of 4. So we're going to do approximately, and then we just do slope formula with these 2 points. So I've got the point 211 and 57. So I'm just going to do 7 minus 11 over 5 minus 2. And that will give me negative 4 over 3. So f prime of 4 is about negative 4 over 3. So that slope would be close to what you're looking for, or as close as you can get given the data that you're getting. All right, so we kind of already did this whenever we were doing some of that velocity stuff. All right, now we have a graph here, and it says use the graph of g of x to the left to estimate f prime of 0, f prime of 6, and f prime of 4. So this is not something you would be asked to do to find exact values on the actual test. What you will see sometimes is they might give you f prime of 0, f prime of 6, and f prime of 4, and ask you to put them in order from least to greatest or something like that. So they are not necessarily asking you to, they're not necessarily asking you to find the exact value, but you might know this one's positive, this one's negative, this one equals 0, so we would be able to put them in order. But if we're just estimating here, if we look at 0, that's right here, and f prime of 0 is not the y value, it is the slope of your tangent line. So if we try to draw in a tangent line there, that looks pretty good, I think. It might need to go up a little. Well, that's pretty good. Not bad there. So we were literally just estimating this. And then whenever we look at our slope of this line, for the one I've drawn in here, it looks like we're going down 1 to the right 3. So my estimate, I'll use the squiggly equal sign, is negative 1 over 3. At f prime of 6, so 6 would be right here on my graph. If I try to draw in a tangent line at that point, I've got this. It's not hitting on grid lines so great. Let's see. It's pretty close to negative 1, isn't it? Like if you went down 1 to the right 1, down 1 to the right 1, I think it's pretty close to negative 1. So we're estimating right here. It's about negative 1. And again, you wouldn't be expected to guess that just right. But what you would be expected to see is that comparatively, first of all, they should both have negative tangent lines. And comparatively, this line is not quite as steep as this line over here. So, if you maybe had negative 1/2 right here for f prime of 0, and then negative 2, well, maybe negative 3/2 or something here, comparatively, you're still in the ballpark, right? Yes. Typically, what you are going to see is that I wouldn't ask you to, estimate these. Rather, like on a quiz or a test, what I would ask you to do is I would say, which of the following is true? And then your answer choices would look like this. F prime of 0 is less than f prime of 6, less than f prime of 4. Even though it doesn't work for this problem because we'll run into a problem with 4. And then f prime of 4 is less than f prime of 6, less than f prime of 0. And so your answer choices would look like that. So as far as finding the actual number, it's not really important. It's being able to tell which one would be higher or lower is what you'll see more on actual test questions. Now, that would be hard to do for this particular problem because f prime of 4, 4 is right here. What is happening at 4? We've got a vertical asymptote. So f prime of 4, that is a derivative at that point, but our function does not even exist at that point, right? So we would say, here's a good question. Is that going to be undefined or does not exist? I don't know if I know the answer to that. I'm thinking that on the AP exam, either would be fine. Right, because it is a limit, and limits do not exist. But using function notation makes me want to think that it's going to be undefined. I'm going to go with does not exist, but it might be undefined. I think this is a technicality where, it's not going. We're not going to run into it actually mattering whether we know which one that's supposed to be, but I'll see if I can figure out which one it should be. Because derivatives we do find using limits, but I'm not 100% sure on that. Either way, we know we can't find that derivative at that point. Okay, so answer this question here. True or false? For all x's in the domain of f, f prime of x is less than or equal to 0. What do you guys think? True or false? Bo says true. Does everyone agree with Bo? Or does somebody think he's wrong? Right. Does not exist is an issue. But the question says for all x's in the domain of f. So is 4 in the domain of f? It is not, because you have vertical asymptote there. So that statement for all x's in the domain of f means looking at every place on this graph except for 4. So that takes care of the issue. Now, if it said for all real numbers, f prime of x is less than or equal to 0, then it would have to be false, because it would include 4, and it does not exist at 4, so that would not be true. But because it says in the domain, that means we're not going to look at 4. So is it true that the derivative is always less than or equal to 0 everywhere except for 4? It would, because if we draw in our tangent lines, even up here, like it's going to be a really flat, but it's still going to be decreasing a little bit, right? Over here, you'll have really steep decreasing lines. When you skip up to this part, all your tangent lines are still going to be negative slopes. So this would be true. Okay? All right, here's some fun questions. We've got to fill in each blank with a greater than or less than sign. So we have to figure out what in the world this is even talking about. This is for this particular graph. And I see f of negative 1 minus f of negative 3 over 2. And I've got f of negative 3 minus f of 5 over negative 8. So you do have the option of like plugging in values from your graph. Although you're going to have to estimate a little bit to do that. Not much on this one. So it gave you pretty nice problems. But what is this doing right here when we're going f of negative 1 minus f of negative 3 over 2? What is that finding? It's not the derivative, because to do a derivative you'd have to have like the limit as something approaches this here. It is the slope of its secant line, right? Between which 2 points? Negative 1 and negative 3. Because think about this, if we did f of negative 1 minus f of negative 3 over, you'd have to have over negative 1 minus negative 3. Right? That would be the slope formula for that, because you'd have the point negative 1 f of negative 1 and negative 3 f of negative 3. And so that'd be slope formula. But in the denominator, whenever you change that to a positive, it becomes 2, so that gives you the same thing as you have here. So if I draw this on this graph here, and I'll use blue for this part, that is the slope of this line right here. Okay? So over here, I've got f of negative 3 minus f of 5 over negative 8. What is this finding? Not slope of the tangent. That slope of the secant between which 2 points? negative 3 and 5. So 5 is over here. I'm going to use red for this one. And so between negative 3 and 5, I'm looking at this line, right? So you could actually try to plug in some values for f of negative 1 and f of negative 3. But if you look at the two graphs, which one has the greater slope, the blue line or the red line? Blue. So we would fill this in with a greater than sign because that blue line is steeper there. Okay, so when I see f of negative 3 minus f of negative 1 over negative 3 minus negative 1, what is that? It's just backwards, but it's the same thing we had in A in blue, right? It's slope of that secant line between negative 3 and negative 1. So that is this blue line right here. What, I'm going to do this one in green. What is f prime of negative 3? Tangent line at negative 3. Now here's where you definitely have to estimate. You couldn't pull numbers off of the graph for this. You've got to draw in, oh wait, hold on. What did I just draw? That's negative 1. Alright, negative 3 is right here. Alright, now the difference is slight, but which one is steeper? The f prime, the tangent line. So we would have our alligator eat the tangent line because this is bigger, so we'll use the less than sign right there. And for C, we're still dealing with that same thing, right? We're still dealing with that slope of the secant line between negative 3 and 1 right there. This time, let me use purple for this one. It's asking us for f prime of negative 1. What is that going to be? Tangent line at negative 1. That's the one I was trying to draw a second ago, right? This one right here. Alright, so if we compare that purple line and the blue line, which one is steeper? Blue. Blue is steeper, so we would have a greater than right there. Okay, questions? Alright. Alright, so for this one we're supposed to label each of the following on the graph and then find the values of each expression. Okay, so f of negative 2, where I didn't label it, but let's assume this is f of x right here. So f of negative 2. What is that going to be? What's that going to look like on the graph? It's just a point, right? So I'm going to use just a black dot right here. Negative 2 right here. This is f of negative 2. So f of something is just a point on that graph. What value would we give for that, for this one? 0. Okay. F of 0. Another point, right? This point right here where x equals 0. What is our value for f of 0 on this graph? It is 4. There. Okay. F of 0 minus f of negative 2. What is that? What value would I get? I would get 4, right? Because I would do f of 0, which was 0, minus f of negative 2. Oh, hold on. got it backwards. F of 0 was 4, and f of negative 2 is 0. So I would get 4. What is that on the graph? It is. It's just like the top part of the slope, right? So the top part of our slope, when we do slope, it's change in y over change in x. So we just found the change in y right here. That's your vertical distance. So if I wanted to label that on the graph, I could label it maybe like this. It's this distance right here. I'm going to draw an arrow to this. That would be f of 0 minus f of negative 2. It's that vertical distance right there. If they had given us the, well, they probably wouldn't for the graph, but negative 2 minus 0, that's the bottom part. That'd be your horizontal distance. Okay, so Connor kind of led us into the next one. What have we got for f of 0 minus f of 2 of negative 2 over 0 minus negative 2? Okay, we will get 4 over 2, which is 2. What is this? How do I label this on the graph? Okay, this little segment here, the slope of that line equals f of 0 minus f of negative 2 over 0 minus negative 2. What in the world is the last one? Besides a headache. Well, I can see pieces of it. What is this piece right here? That is our slope. I got a y right there. I got an x plus 2. It's the equation of the tangent line. Now, when we did it this way. We did y equals that slope, and then we'd have x minus x1 plus y1. But this value right here, could you move it over to this side and it would become plus the f of negative 2, which is a y value, right? So this, all of this right here, which I'm not going to rewrite because it's super long, that would be the equation for the line here. They love in AP problems to not use just straight numbers. They love to use this like f of 0, f of negative 2 notation. Sometimes they might even put like A's and B's instead of numbers, and ask you questions about that. So that's why we're going over these types of problems here. It kind of makes you think about it theoretically instead of just in terms of one specific problem. It's the equation for the secant line. The equation for the line through 0, f of 0, and negative 2, f of negative 2. So it's that secant line. It is possible to have tangent lines that, like, especially whenever you have like these turns in the graph, it is possible, like for example, if we did a tangent line here, right, that tangent line would eventually cross this end of the graph over here. We would still call that a tangent line at that point. So it still gives you the slope of the graph at that point, even if it ends up like hitting the edges of the graph on the end. If you're wanting the slope of the graph at that point, it will give you that information. Now, if you look at it as a secant line where you're concerned about this point and this point, that would be different. But we would still call it a tangent line at that point because it touches for the points near it, it only touches at one point. It doesn't really like cross the graph at that point. It like kisses the graph at that point, so it would still be a tangent line. Okay. All right. These are fun. All right. We have been given a graph of f. This is the graph of f. We are supposed to sketch a graph of the derivative. So, the derivative is the slope of the tangent line. So if we want to graph f prime, let's think about making ourselves like a little table here. X, f prime of x. So if I just start over here where I can see on the graph like at -8. Right. What is, right here at -8, what is the slope? And here's another instance where it kind of doesn't make sense to call this the slope of the tangent line because the tangent line is the line right there because it is a straight line. So when you get down to straight lines, we're really just talking about the slope of the line at that point because you can't really have a tangent to a line right here. So we're just talking about the slope of the line. What's the slope of the line right here? Can we tell for sure? It's a little, I didn't do one that was, looks like it's -2. Does that seem right? Down 2 over 1. It's hitting in between grid lines, so I think it's -2. All right, then at like let's say -6. What's our slope? Still same line, right? If we did -4, we'd get -2, all the way up to -2 would be -2, 0 would be -2. Where do we start to run into a problem? Right here at +2. Oh, what's the slope right there? Yeah, we're not going to be able to find at 2. That's going to be undefined because you can't tell what the slope of that graph is at that point because it's got a different slope from the left and from the right. So we'll talk about that more tomorrow when we talk about differentiability. But we're just going to say it's undefined right there. But then once we switch over here, like if we go to 4, what is the slope of that graph? That's a +2. And then 6 would be +2 and 8 would be +2. Right, so basically what we end up with here is our slope is always the same on the left-hand side of this graph. Then at +2, we switch to having a positive slope for the rest of the graph. So if we were to graph these points for f prime, we would have -8, -2, -6, -2, -4, -2. All this would be -2 until we get up to 2. All the way up to 2, we have that same slope. But I'm going to use a open circle right there because we don't want to include 2. Right? And so on the left-hand side of this graph, I just have a horizontal line at -2. But then at +2, my slope ends up being +2. So if I graph these points over here, I can see that I would have a horizontal line here. I'm also going to use an open circle right here. And I'm going to label this as f prime of x. Okay, so that would be a sketch for my derivative. Okay, this is something we're not getting into major right now, but we're going to do a lot of eventually. Is thinking about what the graph of a derivative would look like. Here's another one, and hopefully I've got a Desmos graph linked to this. That's not this at all, is it? What in the world? Okay, that's this graph here, right? Those are the same. Okay. All right, and then let's see. On a tangent line. I'll tell you what, let me go. I've got a better way for this, I think. I can find the see what this one is. No, not that one. Okay, let's see. Let's do this. Okay. Negative. Okay. Actually, I've just got a derivative graph, I think. Alright, this will be good enough right here. I think I must have messed up whatever graph I was supposed to have. I changed it to something. So, let's do this here. We are going to estimate the slope here. So let's start over here. If I've got, I'm just going to start over here. I'm estimating f prime of x. We'll start at negative 6. At negative 6, so if I move, does that point not move? I might have made this where this point doesn't move. This may not be helpful. Gracious me. I wish I had this that would work. Okay, we're going to have to abandon Desmos because I don't have it set up like it was supposed to be set up. Alright, we're just going to go straight on estimates. Okay, so just looking at it. Just a guess. Alright, so right here at negative 6, if I draw in a tangent line, what's it look like? It's like a vertical line, right? And vertical lines, what are they? What's their slope? Undefined. So that doesn't help us a whole lot. But it does tell me like I probably need an open circle there. At -4, and I'm skipping because so that's right here. Okay, if I draw in a tangent line here, what do you guys think for that? Maybe -1.5? We're just estimating. We're just guessing here, right? We're sketching a graph of the derivative. What about at -2? -1/2, right? Okay. What about at 0? Okay. That tangent line, I feel pretty confident, is going to be horizontal. So that'd be 0. And then this graph is symmetric, so what's going to happen on the other side? If we said -1/2 for -2, what should we say for +2? We should say +1/2. And then 4, we would say +1.5. And then at 6, over here, we're going to run into undefined again. So, just because of the scale here, I'm going to scale it like this. I'm going to say that's 1, that's 2. So, just so that we can see the difference a little bit better. -1, -2. We'll still label these. So if I just graph the points that I have, I've got -4, -1.5. So it'll be here. -2, -1/2. That's here. 0, 0. So it shows up a little bit. 2, 1/2. I've got 4, 1.5. But what's going to happen at the 6 and -6? Okay. Think about what's happening here. Like as I get closer and closer and closer, my lines are getting steeper and steeper and steeper and steeper, right? Till they get to what we would consider infinitely steep, which is the steepest you could be vertical, which is undefined, right? So what I'm probably going to see over here at -6 and at +6 is I'm probably going to see vertical asymptotes. And that would look something like this. Now this is an estimate. We don't have the exact values, of course, but kind of looks like a tangent graph. I don't think it would be a tangent graph, though, based on my knowledge of taking derivatives of that, but gives you an idea. Alright, this one's calculator active. At which x value does f prime of x have the greatest value if f of x equals this crazy function? So let's try to use our calculators. I know Desmos is better, but you can't use Desmos on the exam. So everybody grab your calculators. You can use mine for right now, but you need to locate that. Yeah, look really hard for that over the weekend. I mean, I have more that I can give you, but I am going to have to charge you for that if you can't find it. So, if you can't find it over the weekend, let me know and I can give you another one, but I'll have to turn you in for not having that other one. So, hopefully you can find it. Because they are not cheap. Okay, so we've got this function here, and they say at which x value does f prime of x have the greatest value if we've got this function. So it's not asking us about f itself, it's asking us for f prime, which means the slope of that line, right? So we would like to look at the graph. Let me give you, let's see what it looks like if we just graph it. Oh, mine's not even in standard view right now. Yeah, so this is not in standard view. If I go to F2, which is zoom until it's 6, I get something like this. Now, it would be helpful to me if I had a little better picture of this. So, if you look at your x values that you're concerned with, the ones they asked you about, the lowest one's negative 5.013. The highest one is 0.198. So, something to show you on these calculators. If we go to the window and set our x values like we want them. So, window is the green button and F2. So, green button and F2 takes you to window. And let's do... probably like if we go from -6 up to a +1, right? That gives us a little bit of room on either side of these values that it's asking us for. And that x scale right there, that's what it's going to count by. If you got it at 1, then each tick mark you see there should be 1, unless it should be 1 on this one, I think, because sometimes if you were going from -100 to 20, and you told it x scale was 1, it wouldn't be able to put a tick mark at every point there. So we're going to hit enter. Make sure you hit enter so that you hit enter on both of these before you hit graph. So you're going to green button F3 for graph. And I can see this pretty well here, but a feature that your calculator has is you always want to get your x values right, because zoom fit is not going to change your x values. But if you have your x values right, your calculator will automatically adjust so your y values are like your lowest to your highest. If you go to F2, and I think it's down at the very bottom, there's one, well, it's not the very bottom, it's almost. There's one called zoom fit. It does not change your x values. So if your x values are too big or too small, you may get a crazy graph for this. But if you already have your x values like you want them and you do zoom fit, it may take it a second. But it will graph it so that your lowest x, y value in that window to your highest is given. So it gives you a little better picture. So, did everybody find that? You're going to do your window first, green button, F2 does your window, and then you're going to do zoom fit after that. Positive. Yeah. Well, no. Positive or negative. So it's not asking. So like it's not asking for like the absolute value, like the highest number. So like a -7 would be lower than a +5. Okay. So at -5.013, we're looking over here somewhere. What would you guys estimate that slope to be? It's negative but it's not very steep, right? So let's give it a -1/4. Now, I'm just throwing numbers out there because I don't even know what the y-scale is on this. I'm not sure if that's right. But I'm giving it a -1/4 right there. At -3.531. So 3.531, I bet that's this point right here. What would we estimate that slope to be? I'd say it's probably 0. I should be using squiggly equal signs here because I'm really just guessing. But I got a pretty good idea. This is close to that minimum point, and at that minimum point, you're going to have a tangent line with the slope of 0. Then I've got 0.889, which is probably like here, which is going to be really negative, right? I think we can actually, if you do F3 trace, you won't be able to get like exactly at the point, but we can move our little cursor over. There's 0.822 or 0.911. Those are pretty close. So we're looking over here. That one's really negative. So that would be about negative, I'm going to call it -2. Who knows? But it's bigger. It's more negative than A, right? And then I've got 0.198. So if I go back, uh-oh. Did I come up with this problem? Ooh. Both of those look like they're 0, don't they? So I think if we do F5 value, we could type in 0.198. Well, it looks like it's like your maximum point, doesn't it? Let's do that with, let's move over here to the table will give us the values of this, but won't give us the derivative. Let me go. We might. I think I've just made a bad problem though. This is what's happened. Yeah, we're not going to do that right now though. We don't need to know how to do that just yet. Let's see. I think they're both 0. I think I've made a bad problem. Let me type in the -3.53. Yeah, I think they're both 0. So at which val? Let's amend our question. At which values, x values, does f prime have the greatest value? So what would we say if we had this problem? It would be B and D for this, because I have made a bad problem. Is it? If you do the derivative, it's a little bit different. This question would not be expecting you to use that derivative feature there. So there might be like a technicality. Typically with a question like this, it's obvious, like instead of making, you know what I bet was supposed to happen here? Let's do this. No, that doesn't fix it. Like if I made this -0.198, -0.198, let's do that. Let's do this. That'll be the easiest switch here. Let's make this -0.198, because these problems, the way you'll see them, it is not really expecting to use that derivative feature on the graph, although you could do that. It'll work. To verify. But at -0.198, what kind of slope do we have right there? If we look, that would be like somewhere around here. What kind of slope do we have? It is positive. We're going to say about 1. I'm just throwing numbers out there, but it is positive. So what you would see on a problem like this is there would be usually a negative, a 0, and a positive, and then maybe another negative or another positive. But between the two negatives, you could tell which one is steeper. So since this is the only one where you have a positive slope, this would be your answer if it was correct like it was supposed to be. Where I gave you both of those values being at maximum minimum points where you got 0, it was a bad question. Okay, questions? Okay, this is not really what we're going to do for our assignment, so don't do that book work. Instead, yeah, we are not going to do that book work at all. So you don't
He's going to do it.
I mean, you can have fun if you want. It won't hurt you. But instead, you guys have a review. This has a little bit from everything we've done in Chapter 2 so far. So some of these are like tangent line sort of problems. Notice it does have a calculator next to some of these. And Desmos should work for, I think, these. So yes. So right now, just use Desmos. If you can't find it by next week, I'll use the calculator. But then I'll have to turn you in as a debtor.